Somewhere out there, past every galaxy you've ever seen in a photograph, there's a place where nothing lives. Not nothing like a desert. An absence so total that in a ship traveling at the speed of light, you could travel for 1,000 years and never pass a single star. Astronomers gave it a strange, almost gentle name, a void. But that word doesn't come close to what it actually is. This isn't empty space the way the gaps between planets are empty. It's a wound in the structure of the universe itself, a region hundreds of millions of light years wide where galaxies simply stopped forming. Scientists call the most extreme of these places supervoids, and some cosmologists now suspect our own galaxy might be sitting near the edge of one. Stay with me, because by the end of this, you're going to understand why a supervoid might be the most disquieting object in the observable universe. Not because of what's inside it, but because of what it's quietly telling us about everything else. Let's start with the one that started it all. In 1981, astronomer Robert Kirshner was mapping galaxies toward the constellation Bootes, expecting the usual scatter of light. Instead, he found a hole, a region nearly 330 million light-years across, containing barely 60 galaxies, where a normal patch of space that size should hold tens of thousands. His own team half-joked that if our galaxy sat in the middle of it, we might not have known other galaxies existed until decades later, because there simply wouldn't have been enough light reaching us to notice them. They named it the Bootes Void. Some call it, more simply, the Great Nothing. Here's where it gets strange. A void like this isn't actually empty. It still contains gas, dark matter, the occasional lonely galaxy drifting through the dark like a lost ship. But compared to the universe around it, it's missing the vast majority of its expected mass. Cosmologists measure this with something called a density contrast. And in the deepest, oldest voids, that contrast can mean the region holds only about 20% of the matter you'd expect to find there. 20%. Everything else, gone. Not destroyed, just never gathered. That raises the question that keeps cosmologists up at night. Why there? Why did some patches of the infant universe clump together into blazing galaxies, while others, sitting right next door in cosmic terms, went almost completely dark? The answer takes us back further than almost anything else we can talk about. Back to the first fraction of a second after the Big Bang, when the universe was smaller than an atom and quantum fluctuations, tiny, random flickers in the fabric of existence, decided which regions would be slightly denser than others. The denser spots pulled in more matter through gravity over billions of years, growing into galaxies, then galaxy clusters. The slightly emptier spots lost that gravitational tug-of-war, matter draining away toward their richer neighbors, leaving behind exactly what we now call a void. The emptiest places in the universe aren't accidents. They're its earliest scars, imprinted before atoms even existed, still visible billions of years later, if you know where to look. Here's the part that should genuinely unsettle you. Once a void starts forming, it doesn't just sit there quietly losing matter. It actively pushes outward, because a void has so little mass and so little gravity. The normal expansion of the universe barely gets resisted inside it. Everything around a void gets pulled inward by gravity, toward denser regions nearby. But inside the void itself, there's nothing to pull back. So the void expands faster than the space around it, growing like a hole in fabric that someone keeps stretching from the outside. Some researchers describe this the way you'd describe a hill instead of a valley. A particle drifting into a void would actually slow down, the way a ball slows climbing uphill, moving away from the gravitational pull of everything dense around it. Fall into a void, and the universe itself gently pushes you back out. Voids like Bootes aren't rare exceptions either. As astronomers have mapped more of the sky, they've realized something that reframes the picture. Once you account for how voids overlap and merge over cosmic time, the majority of the volume of the observable universe, by some estimates, is technically void. Not galaxies, not stars, not the shimmering web of light we point our telescopes at. Emptiness, stretching in every direction, with galaxies clustered along its edges like moisture beading on the surface of a bubble. Think about that. When you look up at a clear night sky, you're not seeing a representative sample of the universe. You're seeing the crust, the thin, bright skin stretched across something far larger and far darker underneath. And Bootes, as enormous as it is, isn't even close to the largest one we know about. There's a structure called the Giant Void, discovered more recently, that may stretch for well over 1 billion light-years. So large that some astronomers have questioned whether it fits comfortably inside our standard model of how the universe is supposed to look on the largest scales. A void that size isn't just a gap, it's an anomaly. A patch of the cosmos so profoundly underdense that its very existence has become a genuine point of scientific debate, one some researchers argue shouldn't statistically exist at all, given how rare structures that large are supposed to be. Nobody is certain yet what that means. It could be an extreme but ordinary product of how matter clumped together in the early universe. Or it could be a hint that something in our understanding of cosmic structure is incomplete. Either way, it's a reminder that even after a century of modern cosmology, the universe is still capable of showing us something too big, too empty, and too strange to fully explain. And we're only getting started. Now let's talk about the one that made cosmologists genuinely nervous. In the early 2000s, a satellite mission was mapping at the oldest light in the universe, the cosmic microwave background, the faint afterglow left over from the Big Bang itself, stretched and cooled by billions of years of expansion, until it shows up today as a faint microwave hiss coming from every direction in the sky. It's supposed to be almost perfectly uniform. Tiny variations, sure. Ripples smaller than a fraction of a degree, but nothing dramatic. That uniformity is one of the foundations of modern cosmology. And then, in the direction of the constellation Eridanus, they found something that didn't fit. A cold spot. A patch of sky measurably, stubbornly colder than everywhere around it. Larger and more pronounced than anything the standard model comfortably predicted. Scientists ran the numbers, and some described it as a statistical outlier so extreme it shouldn't reasonably exist. The kind of anomaly you might expect to see by chance once in many thousands of similar skies. And yet there it was, sitting quietly in our one actual sky, refusing to be explained away. For years, nobody was sure what they were looking at. Was it a flaw in the instruments? A statistical fluke? Or was it something real, something physical, hiding behind the data? Then a team of astronomers pointed a ground-based telescope directly at that patch of sky and started counting galaxies. And what they found lined up almost perfectly with the cold spot. A colossal region of significantly reduced galaxy density, roughly 1 billion light-years across, one of the largest structures ever mapped by human beings. They called it the Eridanus Supervoid. Here's the theory, and it's a genuinely elegant one. Light doesn't travel through empty space for free. As a photon from the early universe crosses a void, it has to climb out of a very slight gravitational dip, the same way a ball loses a little energy rolling up a hill. In a universe that wasn't expanding, that energy would come right back once the photon rolled back down the other side. But our universe is expanding, and dark energy is accelerating that expansion. So by the time the photon finally climbs out of the void itself has stretched wider, flatter, shallower than it was when the photon went in. The energy the photon spent doesn't fully return. It arrives at our telescopes very slightly cooler than it should be. Multiply that tiny effect across a billion light-years of empty space, and you get a cold spot large enough to make it into satellite data from across the universe. It's called the integrated Sachs-Wolf effect, and if it's the real explanation, it means we're looking at a kind of fossil. Fossilized starlight, sure, but also something stranger. A fossil of emptiness itself, a place so devoid of matter that its absence left a permanent, measurable scar on the oldest photograph of the universe we have. I want you to sit with that for a second. This isn't a void we're inferring exists because we can't find galaxies in a telescope image. This is a void that left a fingerprint on light that had already been traveling for billions of years before Earth even finished forming. A void so large, so persistently empty, that the universe's own oldest light couldn't pass through it unmarked. Not every cosmologist agrees this is settled science, and it's worth saying that clearly. Some researchers have argued the statistical case for the Eridanus supervoid explaining the full size of the cold spot is weaker than it first appeared, that the void may only account for part of the temperature dip, with the rest coming from ordinary statistical noise in an expanding universe with billions of data points. The debate is very much alive in the research literature, still being argued over in conference rooms and journal submissions right now in 2026. But even in the most conservative version of this story, something remarkable remains true. A supervoid, a region defined almost entirely by what isn't there, is large enough and empty enough to leave a visible mark on the most ancient light in existence. Not through explosions, not through radiation, just through absence, stretched across a billion light years, patient enough to outlast galaxies. There's something almost poetic and deeply unsettling about that. We usually think of cosmic mysteries in terms of things: black holes, neutron stars, colliding galaxies, violent and bright and undeniable. But here is a mystery built entirely out of nothing, a hole in the fabric of matter, quiet and cold, that somehow left its signature on a photograph of the universe taken almost 14 billion years ago. Proof that absence itself can echo across the entire observable universe, loud enough for our instruments to hear it, even when there is never anything there to make a sound in the first place. Now here's the part of this story that stops being about some distant patch of sky and starts being about the address you actually live at. Because a growing number of cosmologists suspect that we might be sitting inside a supervoid ourselves. It's called the KBC Void, named after the three astronomers who mapped it: Keenan, Barger, and Cowie. And if it's real, it's staggering in scale. Roughly 2 billion light-years across, making it one of the largest structures ever proposed in the observable universe, with our own Milky Way sitting not at the exact center, but somewhere near it, off to one side like a single house standing in a mostly empty field the size of a small country. Inside that field, the density of galaxies is estimated to run roughly 20% below the cosmic average, not empty in the dramatic science fiction sense. We're still surrounded by galaxies, still part of the local group, still gravitationally bound to Andromeda and dozens of smaller companions. But zoom out far enough, past our immediate neighbors, past the nearest clusters, and the region we call home starts to look thinner than the regions around it. Emptier, a quiet suburb on the outskirts of a much denser cosmic city, one we've been calling ordinary for as long as we've had telescopes. For a long time, this idea sat at the edge of cosmology, interesting but unconfirmed. The kind of theory astronomers would mention with a raised eyebrow rather than full confidence. But it kept resurfacing year after year, survey after survey, because it kept explaining something that otherwise made no sense. Here's the problem it might solve. When astronomers measure how fast the universe is expanding using two completely different methods, one based on the afterglow of the Big Bang, the cosmic microwave background, and the other based on nearby exploding stars called supernovae. They get two different answers. Not wildly different, but different enough, and measured precisely enough across years of increasingly careful observation that it isn't a rounding error. It's a real disagreement, and it's been getting harder to explain away with each new generation of telescopes and each new data set. Scientists call it the Hubble tension, and it's considered one of the most important unresolved problems in cosmology today. If we happen to live inside a large, underdense region that could change the local numbers, a void has less gravity holding back the expansion inside it, which means galaxies near its edges could appear to be receding faster than galaxies would in a denser, more typical part of the universe. Measure the expansion rate using only our local neighborhood, and you might get a number that's subtly, systematically off. Not because the universe as a whole is behaving strangely, but because we happen to be observing it from an unusually empty room. Sit with that for a moment. It's possible that one of the deepest, most stubborn puzzles in modern physics, a disagreement serious enough to make headlines in scientific journals for over a decade, might partly come down to something as simple as our cosmic address. Not a flaw in the laws of physics, a flaw in assuming our little patch of the universe is representative of the whole thing. I want to be honest with you about where the science actually stands, because this is exactly the kind of idea that's easy to oversell. The KBC void theory is not settled. Some researchers find the evidence compelling, pointing to galaxy surveys that do show a genuine dip in density around us, consistent across multiple independent studies. Others remain skeptical, arguing the void, if it exists at all, isn't large or empty enough to fully account for the Hubble tension on its own, and that the real answer might involve new physics entirely, something about dark energy or the very early universe that we haven't figured out yet. Missions built specifically to map cosmic structure with unprecedented precision are actively gathering the data that should help settle this, piece by piece, over the coming years. But even as an open question, it changes something. For most of human history, we assumed our position in the universe was, at the very least, ordinary. Not special, not central, but not strange either. Just an average patch of cosmos, like any other, one of countless similar neighborhoods scattered across an unimaginably vast sky. The KBC void theory suggests something quieter and stranger, that maybe we're not standing on ordinary ground at all. That maybe, without ever realizing it, humanity has spent its entire existence looking out at the universe from inside a very large, very quiet room. And only now, with instruments precise enough to notice, are we starting to realize the walls are further away and the room emptier than anyone ever expected. Let's go back inside a void for a moment, because here's something that might surprise you. Voids aren't perfectly, mathematically empty. Every now and then, against every statistical odd, a galaxy manages to form right in the middle of one. Alone. There's a galaxy called MCG plus 0102015. A barred spiral not unlike our own Milky Way in shape, sitting almost exactly at the center of the Bootes void. And when astronomers checked its surroundings, they found something that's hard to fully picture. No other galaxies, not a few, not scattered ones far in the distance. Nothing for roughly 100 million light-years in every single direction. As far as we know, it's the loneliest galaxy in the observable universe. Now, think about what that actually means for a moment. Andromeda, our nearest large galactic neighbor, sits a little over 2 million light-years from us. That's already a distance so vast it takes light itself 2.5 million years to cross it. MCG plus 0102015's nearest neighbor is roughly 40 times farther away than that. If the Milky Way is a house on a street with neighbors within walking distance, this galaxy is a single house standing alone in the middle of an ocean. With the nearest shoreline so far away it might as well not exist. Here's the part that genuinely stops me every time I think about it. Astronomers have pointed out that if intelligent life had evolved inside that galaxy instead of ours and built telescopes at roughly the pace we did, they wouldn't have discovered a single galaxy beyond their own until the 1960s. For the entire history of their civilization, every philosopher, every early astronomer, every person who ever looked up and wondered what else was out there, the answer, as far as their instruments could tell them, would have been nothing. Just their own galaxy, alone, floating in a perfectly dark, perfectly empty sky, with no way of knowing that anything else existed at all. We take for granted that the night sky is full of light. Even without a telescope, we can see Andromeda with the naked eye if the sky is dark enough, along with the Magellanic Clouds and Triangulum. 4 separate galaxies visible to the human eye alone, long before anyone invented an instrument to study them. That accident of geography quietly shaped the entire arc of human cosmology. It's part of why we figured out, relatively early, that we live in a universe full of other galaxies, other possibilities, other places. A civilization born inside a void wouldn't have had that gift. Their entire understanding of existence, for as long as their species survived, might have stayed centered on a single galaxy, alone in an ocean of dark that looked, for all purposes, like the whole of everything there is. It raises an uncomfortable thought experiment. How much of what we believe about in the universe, its size, its structure, the sheer abundance of galaxies stretching in every direction, is actually true of the universe as a whole, and how much of it is simply true of our particular, unusually crowded neighborhood? We assume our view is representative because it's the only view we've ever had. But somewhere out there, in a galaxy like MCG plus 0102015, if anyone was ever there to look, the universe would have told a completely different story. Not a false one. Just a story shaped entirely by where the storyteller happened to be standing. And it's not the only one. Astronomers have identified other isolated galaxies scattered through nearby voids. Smaller ones, dimmer ones, dwarf galaxies drifting through the emptiness with essentially nothing gravitationally bound to them at all. One, called K8 246, sits inside what's known as the local void, close enough to us, cosmically speaking, that we can study it in real detail. And it remains the only galaxy confirmed to exist inside that particular void. A single point of light, surrounded by structure it will likely never meaningfully interact with for the rest of its existence. There's something almost tender about these galaxies, if you let yourself think about it that way. They didn't choose their isolation. Whatever slight imbalance in the early universe placed a pocket of gas exactly there, in exactly that much empty space, set the entire story in motion before the galaxy itself had a name, before there was anyone to ask why. It simply formed alone, and has stayed alone for billions of years, spinning quietly through a darkness that will likely outlast every observer who has ever wondered what it's like to be it. We'll never know for certain what it would feel like to look up from a world inside that galaxy. But maybe that's exactly the point. Somewhere in this universe right now, there may be a sky with nothing else in it at all, and everything we've ever believed about how crowded, how connected, how full the cosmos is, might simply be a story written by the neighborhood we happened to be born into. Here's the thought that should really keep you up tonight. Voids aren't just something that already exists out there, in some distant patch of sky. They're something the entire universe is slowly turning into. Because of dark energy, that mysterious force accelerating the expansion of the universe, space itself is stretching faster and faster with every passing billion years, And the key thing to understand is that dark energy doesn't care what's already gravitationally bound together. Galaxies, clusters, anything already held tightly by gravity stay held together, but anything not already bound gets pulled apart faster and faster forever, which means the universe isn't just expanding, it's sorting itself. Splitting into isolated islands, drifting apart from each other at an ever-accelerating rate, with more and more genuinely empty space opening up between them. Cosmologists actually have a name for what those islands eventually become. They call them island universes, not a metaphor, an honest description of what galaxy clusters will eventually turn into. Self-contained, gravitationally sealed bubbles, drifting alone through an ocean of expanding darkness, permanently cut off from everything outside them. Here's what that means for our own galaxy specifically. Billions of years from now, the Milky Way and Andromeda will have merged, along with the rest of our small cluster, into a single galaxy. And everything beyond that merged structure, every other galaxy, every other cluster, everything that isn't already gravitationally bound to us, will have crossed a boundary called the cosmic event horizon. Their light won't be blocked. It'll just be stretched, redshifted, farther and farther, until it fades below any threshold we could ever detect, no matter how sensitive our instruments become. Some physicists have run the numbers on what an observer in that far future would actually see, and the answer is genuinely eerie. A single galaxy, just one, surrounded by nothing. No visible expansion, because there'd be nothing left nearby to measure the expansion against. No evidence from where they're standing that a Big Bang ever happened, that other galaxies ever existed, that the universe was ever anything other than one quiet island of stars, floating alone in permanent darkness. Think about what that means for science itself, not just for the stars. A civilization born early enough. Us, right now, in this narrow window of cosmic history, gets to see the full picture. Other galaxies, the cosmic microwave background, the afterglow of the Big Bang itself, still faintly detectable, still telling its story to anyone with the right instruments. But a civilization born late enough, in that same universe, wouldn't have access to any of it. They'd look at the sky, study their one galaxy in exhaustive detail, and reasonably, honestly, conclude that the universe was static, small, unchanging, not because they'd be wrong to trust their observations, but because the evidence that would have told them otherwise will have permanently vanished beyond their horizon, long before they ever existed to look for it. We are, in other words, living in something researchers have started calling a privileged epoch. Not privileged in a comfortable sense, privileged in the sense of timing. Early enough that the sky is still full of galaxies. Early enough that the universe still shows its own history, written in the light reaching us from every direction. Long after we're gone, that window closes. Not with an explosion, not with any dramatic event at all. Just quietly, gradually, the way it's already happening to the voids we've been talking about this entire video. Expansion, patiently doing its work, until what was once a universe full of light becomes, from any single vantage point, one dim island in an endless black. There's something strange about realizing that the very structures unsettling us in this video, the voids, the emptiness stretching between galaxies, aren't an exception to how the universe works. They're a preview, a rough draft of what everything eventually becomes. The Booty's void, the Eridanus supervoid, the vast quiet region we might be living inside right now. They're not cosmic accidents happening somewhere else. They're the future, arriving early in specific places for reasons we're still working out. Maybe that's the real story hiding underneath all of this. Not that the universe has empty places in it, but that emptiness is where the universe is headed, everywhere, eventually. And we happen to be here early enough, right now, to watch it while there's still enough light left to see it happening. If you've stayed with me this far, thank you. Genuinely. This isn't the kind of video designed to grab you for 15 seconds and let go. It's the kind that asks you to actually sit with something strange, something quiet, and let it change how you look at the sky the next time you're outside. If that's the kind of thing you want more of, consider subscribing. We put out something new like this every single day, and I'd love to know in the comments, does knowing any of this change how you'll look up at the stars tonight? Okay, back to it, because there's a question we haven't answered yet, and it might be the most important one in this whole video. How do scientists actually map something that's defined almost entirely by its absence? You can't point a telescope at nothing and take a clean photograph of it. So how do we actually know these voids are really there, really that shape, really that empty? The answer involves one of the most ambitious mapping projects in the history of astronomy. For decades now, teams of astronomers around the world have been measuring the position and precise distance of literally millions of galaxies, one at a time, patiently building an actual three-dimensional map of the universe around us. Not a flat picture of dots on the sky, the way ancient astronomers mapped constellations by eye, but real depth, how far away each individual galaxy actually is, layered together into a structure vast enough that you could, in principle, fly through it. When you plot all of that data at once, something remarkable happens. The random scatter of galaxies resolves into a shape, not a formless cloud, but something almost architectural. Long filaments of galaxies stretching across hundreds of millions of light years, intersecting at dense nodes called superclusters, with the whole structure looking, from far enough away, unnervingly similar to a biological network. Neurons firing across a synapse, blood vessels branching through tissue, the root system of an old forest spreading beneath the soil. Scientists genuinely call it the cosmic web, and once you've seen a rendering of it, you can't unsee the resemblance. This vast, glowing lattice that every galaxy, every star, every one of us technically hangs from, stretching further than the human mind is really built to hold. And the voids are simply the empty chambers inside that web. Not gaps we're inferring exist because we haven't looked hard enough in the right direction. Gaps we can directly count, directly measure, directly walk through in these three-dimensional maps, galaxy by missing galaxy, region by underdense region, confirmed the same way you'd confirm a room is empty by walking through it with the lights on rather than guessing from outside the door. Here's what makes this genuinely important, beyond the sheer strangeness of it. Voids turn out to be one of the most sensitive tools cosmologists have for testing our entire model of the universe. Because a void's size, its shape, how fast it's growing over cosmic time, all depend on the details of dark matter and dark energy, the two components that together make up the vast majority of everything that exists, and that we still don't fully understand at a fundamental level. Change your assumptions about how dark matter behaves even slightly, and the predicted size and number of voids in the universe changes right along with it. Which means every new void we map, every unexpected shape or size we stumble across is, in a very real sense, a fresh piece of evidence about the deepest, least understood parts of physics itself. Evidence hiding in plain sight, in the shape of nothing at all. New sky mapping missions, built specifically for this kind of work, are actively gathering data on tens of millions of additional galaxies right now, expanding these three-dimensional maps further and more precisely than ever before in human history. Every void they confirm, every unexpected shape they find sitting where the standard model didn't quite predict it, either confirms our current understanding of the cosmos, or quietly hints that something in the model needs to change. There's something almost moving about that, if you sit with it. We spend so much of our energy searching for things: new planets, new particles, new signals from deep space, new galaxies blazing at the edge of what our telescopes can reach. But some of the most important discoveries in modern cosmology have come from carefully, patiently mapping what isn't there at all, counting the silence, measuring the shape of an absence with the same rigor we'd use to measure a star. It turns out that nothing, mapped precisely enough, could tell you almost everything about what the universe actually is. So here's where all of this leaves us. A hole in the sky nearly 330 million light-years wide, sitting quietly since before there were eyes anywhere to notice it. A cold spot in the oldest light in the universe, possibly carved by 1 billion light-years of emptiness that light itself had to climb through. A void we might be living inside ourselves, right now, without ever having felt it, quietly reshaping how we measure the entire expansion of the cosmos. A galaxy, utterly alone, with nothing but darkness for 100 million light-years in every direction, having no way of knowing anything else exists at all. In a future where all of this, the emptiness, the isolation, the quiet, isn't the exception to how the universe works. It's the destination every part of it is slowly, patiently drifting toward. None of this changes anything about your day tomorrow. You'll walk outside, look up, and the sky will look exactly the way it always has. Scattered light, familiar constellations, the same quiet dome you've been looking at your entire life, unremarkable, ordinary, exactly as it's always seemed. But you'll know now what's actually sitting behind it. That some of what looks like plain darkness between the stars isn't just distance, isn't just empty space waiting to be filled. It's structure, it's history, it's the universe's oldest scars, imprinted before atoms even existed, still shaping the light that eventually reaches you, still quietly deciding, in ways we're only beginning to understand, what our entire picture of reality actually looks like from where we happen to be standing. That's not nothing. That might be one of the strangest, most humbling things you'll learn all year. That absence itself, mapped carefully enough, can tell a story as real and as important as anything made of light. If this changed the way you think about the night sky, even a little, do one thing for me. Share it with someone who'd actually appreciate it. Not because it needs to go viral, but because this is the kind of thing worth knowing together, not alone, in the same quiet way the loneliest galaxy in the universe never got the chance to. And if you haven't yet, follow the channel. We do this every day. Before you go, tell me something true in the comments. What part of this actually stayed with you? And tell me what you want me to dig into next. What question about this universe, this strange, mostly empty place we all somehow call home, keeps you up at night? I read every single one. I'll see you in the next one.